In our conversation today, we're going to learn about buffers. So these are the solutions that prevent the change of pH when small amounts of acid or base are added to that solution. They work because they are the system of either a weak base and its conjugate acid or a weak acid and its conjugate base in the form of a salt. For instance, here you have a weak acid, which is carbonic acid, and the conjugate base, which is bicarbonate anion. This is the bicarbonate buffer system found in the blood, and it allows to maintain the blood in the normal pH range between 7.35 to 7.45. When the capacity of a buffer to maintain pH is exceeded, the people can develop acidosis or alkalosis. Basically, at this point, the capacity of the blood to maintain pH is simply overwhelmed by the amount of acid or base produced within the body. So just as it is suggested as is guided in the lab, I've got 6 tubes that each contain, first 2 tubes contain carbonate buffer, 3 and 4 contain phosphate buffer, 5 and 6 contain water. Each tube received 4 drops of universal indicator, and now we're going to determine the pH of each solution. So using this comparison chart, we can see that pH of the carbonate buffer is slightly basic, around pH 8. The pH of the phosphate buffer and water is approximately 7. Now I'm going to add 1 drop of hydrochloric acid to the tubes 1, 3, and 5. Let's mix it thoroughly. By pipetting up and down, you can see that only tube with water changed its color. Next, I'm going to add 1 drop of sodium hydroxide to the tubes 2, 4, and 6. So you can see that only water changed the color dramatically. And now we're going to determine the pH of all these solutions after the addition. So let's take a look. This is for carbonate buffer. You can see that the color of the pH indicator paper corresponds to basically same pH 8. In terms of the phosphate buffer, pH didn't change much, so same 7 and 7. And what about water? So this became dramatically more red, and this became kind of towards 10 to 11, maybe even 12. So 12 for water, it is 12. You can see after the addition of sodium hydroxide, and it is closer to 2. After the addition of acid. Now the very last step would be to add 3 full droppers of acid to test tube 1. One, 2, 3. You see that the color of the tube dramatically changed. We overwhelmed the capacity of buffer to buffer it, and you see all the bubbles. That's carbon dioxide being released from reaction. Now what's the pH? Well, you can, I'm trying to center it, you can fairly clearly see that it's between pH 2 and 1. So now, using the data that we just obtained, you can first of all fill out this whole table with the original pH, pH after acid, after base, after excess acid. So 1 drop of acid did not change pH in tubes 1 and 4 because those are buffers, but 5 and 6 is water, so it did change. And pH of test tube 1 changed after excess acid because the buffer capacity here was overwhelmed by the amount of acid that ended up being added.